In this video, we will look at sketching the graph of a logarithmic function by applying transformations. We will take a look at the parent function to the logarithm, the related exponential function, the inverse of that particular logarithm, and then the transformation that would be applied. Our first example, sketch f of x equals logarithm with base 3 of x minus 2. So in this particular case, the parent function would be y equals logarithm base 3 of x. That would be the basic logarithmic function that this is built off of if we ignore the transformations. What can be helpful when working with logarithm functions is to think about the related exponential function, which in this case would be y equals 3 to the x. Or instead of saying the related exponential function, it would be the inverse function. Y equals 3 to the x and y equals logarithm base 3 of x are inverse functions. And then the last piece of this would be to identify the transformation that's going on. In this particular case, the minus 2 is going to give us a shift to the right 2 units. So those three pieces of information are probably the three pieces of information that you should gather together when faced with graphing a logarithmic function to start. So what we'll do here is let's just build a set of points off of the exponential function. Most people find that easiest to do. We'd have the point 0, 1 because 3 to the 0 power is 1. 1, 3 because 3 to the first is 3. 2, 9 because 3 squared is 9. And 3, 27 because 3 cubed is 27. Now at the same time, we should probably also think of a few points using negative x coordinates here. Negative 1 1/3 and negative 2 1/9 are probably enough to do that. Now, if I go so we can see the whole thing there. Now what we're going to do is we're going to use the relationship between a function and its inverse to create points on the parent function for the logarithm. The graphs of inverse functions are related to each other by reflecting over the line y equals x. Now the math that we need to accomplish a reflection over the line y equals x is going to be that we need to switch the x and y coordinates. That's what we need to do here. So to create the points on the parent function, the y equals logarithm base 3 of x, I would have 1 0, 3 1, 9 2, 27 3, 1/3 comma negative 1, and 1/9 comma negative 2. I'm writing all this out. When you become more proficient, you could probably just think your way through this and just write the stuff that we're going to have in the last column here. Our last piece would be to apply the transformation shift to the right 2 units. One helpful thing is to identify what math needs to be done to accomplish that shift. Since it's a shift to the right, that means it's a horizontal shift, so we're going to be affecting the x-coordinate. And if we move to the right, the x-coordinate is going to get bigger. So the math that we need to accomplish a shift to the right 2 units is to add 2 to our x coordinate. I put an R in there, coordinate. If you want, you could pause the video here, try to do that yourself, create the column of points in green that I'm going to have in a moment, and then come back and check your solution. Excuse me. So here, when we have our points and we add 2 to each x coordinate, we would have 3 0, 5 1, 11 2, 29 3. And then when I add 2 to a 9th, to a third, I could really write 2 1/3 negative 1, and I could write 2 and a 9th negative 2. And now that I have those points, I can use them to create my graph. So I'm going to switch slides here, and I'm going to need to use those points, and I might flip back and forth, but I need to have a graph here. knowing what I know about the graphs of untransformed logarithms, I really am only going to need quadrants 1 and 4. And I'll go something like this. And typically with logarithmic functions, the x-coordinates grow fairly quickly. And you see if you look at your list of points in green, that I wrote in green, that the x-coordinates get pretty big. But the y's don't grow terribly fast. I'm looking at what I had, and I needed to get out to about 30-ish. So I'm gonna go by 2's here, 2, 4, 6, 8, and I'll put a 10 there, 20, 30. But my x's don't need to grow terribly fast. You might want to pause the video here, create your own graph if you try to do this yourself. Otherwise, if you're just following along, you can just follow along. The other thing that I know is that typically logarithmic functions have vertical asymptotes at the y-axis. But because of my horizontal translation to the right, the vertical asymptote is going to get moved 2 units over as well. I better make that vertical. And so typically, the asymptote would be on the y-axis here. But since I have everything being shifted to the right 2 units, I'm going to shift that to the right 2 units as well. And now I will plot my points. Let's see, what did I have here? 3, 0, and 5, 1. You might want to, if you're trying to do this on your own, you're practicing, you're studying, you're trying to get better, you might want to pause it, try to make the graph yourself, come back and look at this yourself. So if I have 3, 0, and let's see, 2, 5, 1. After that, I had 11, 2, and 29, 3. 11, 2, and 29, 3. And then when it comes to these points that have, fractional coordinates, you just do the best you can, get them into place, because that's going to help you indicate your asymptote. We had 2 and a third, negative 1, and, 2 and a ninth, negative 2. And so we end up with the graph of y equals logarithm base 3 of x minus 2 by using the parent function, the related exponential, that is the inverse, and then applying transformations. And that is the graph of y equals logarithm base 3 of x minus 2. I hope you found it helpful. You can look for some other examples as well. Thank you.